Yeah, welcome everyone. So when the schedule came out, it was like, oh, that sounds like two completely identical talks, so maybe we have to distribute it somehow. And yes, indeed, I also wanted to give a short introduction into what Docker is, and gladly I can skip that over because there was a very good introduction before. So I can concentrate on what I'm interested most, and that is ranting. So I will concentrate on what's the bad thing maybe about still 2019 Docker and especially Python. So who read my abstract maybe already knows, maybe some others do not know. It is a little known fact that actually Docker was first shown to public at a PyCon. So exactly at the same conference like this year, but not in Germany, in the US. And it wasn't a keynote or something. It was a lightning talk. So who joined the lightning talks yesterday? So go there. I mean, sometimes there's awesome stuff presented. I mean, that was somehow a revolution. So this year Solomon Hykes, and he showed in 5 minutes a new thing, and he said, it's something with containers, and so he did this live demo, and he showed, okay, Docker run. I mean, it looks exactly the same like now 6 years later. So it was quite impressive at that time. So people were like, boom, what's happening there? What can we do now? The world has changed. Remarkably, in the exact same lightning talk, 1 minute later, he already threw out the first garbage into a container, so he misspelled "Hello World," and I think this should go into a museum, because I mean that's kind of awesome, right? And it's printed so many times, so I think that's really great. So a very short introduction, but I will only concentrate on the things that are relevant to understand all the stuff behind it. So we already heard in the talk before, Docker is not the same thing as a virtual machine. So here, if we want to depict what a virtual machine is, it's really an emulation or simulation of a whole new computer inside a computer. So it's a virtual machine. That's why the name is like this. So we really virtualize things like CPU, memory, disk, and there's a hypervisor doing all the things. So in the end, it's really, like we heard already, it's a new operating system emulated by a computer. Docker is something completely different. So in the basics, it's something like people who are familiar with Linux, they knew things like change root a long time before. So in principle, Linux is just a file system. So if you add a USB drive into your computer, a file is created somewhere, /dev and stuff. So you can have a new operating system just by copying all your files and move it to somewhere else, here into a subtree. And then you can do a command doing change root, and now you have a new operating system. But it's just new files. I mean, the same kernel is still running, and then Docker just, as we already heard, is just adding some stuff around it. So things like C groups for isolating resources like memory or CPU or networking stuff, and namespaces to separate the processes so they cannot really see each other and things like this. So more or less, it just adds up such that it feels like a virtual machine, a complete new operating system, but it is not. It is the same operating system. It just uses a different file system there. So I like this picture a lot. So you can think of containers a little bit like this. So there's the stick in the middle, which is the kernel, and each container is just like a ring. So they share all the same container, whereas in a virtual machine, you would have many sticks, one stick for each new virtual machine. Now there's a problem. So I told you that Docker is not a virtual machine, but Docker is not a virtual machine on a Linux system. Most of you, I guess, will not have Linux on. Who has Linux on his local? Okay, that many. So roughly a third, maybe. So 2/3 have a machine like Windows or a Mac. And indeed, I mean, at least at each and every single Docker container is running in a virtual machine if you're using something like Mac or Windows. So that's a crazy situation. You build up a virtual machine, and in the virtual machine you install Docker, and then you have these many containers inside the virtual machine. And of course, this creates problems. So, for example, I will concentrate on Mac because I have a Mac. So, but it's in principle it's the same on Windows. So Docker on Mac, if you just install Docker for Mac, then there is a special VM. It's created just for the purpose of hosting these Docker containers. And at least in my experience, so most problems, if you have any, is the bottleneck is the mounted file system somehow. So somehow file system access from your host machine to your Docker containers. So it's not about the CPU usage of these virtual machines. Virtual machines are really efficient these days. So it's not about, oh, my virtual machine is eating up all my CPU. Most of the time, if you look into it, it's just the file system somehow the bottleneck. And this is why you can improve the situation a bit. So if everything is up and running and you have no problems, then be happy. There is no problem for you. But I mean, for example, in our company, we have most of the developers have Mac, and there's not a day where there's no complaint about anything concerning Docker. So one remark is just there in the Docker program on the Mac, you can decide which parts of the file system, which folders are mounted into the virtual machine. So not into a volume in the Docker container, but for the whole virtual machine. And normally it's something like users. So everything is mounted into the virtual machine. So if you experience some problems, it might be a good idea to reduce it to really just the part of the file system which you're actually trying to use inside the Docker containers. For example, the folders where your source files are. Then also use as little volumes. So if you want to attach a volume into a Docker container, then also be sparse there. So don't just mount your whole file system into your Docker container for convenience, because then it's there and you can access everything. Just mount the sub part what you're using inside the Docker container. Then there are some, I mean, this really goes into details, and it goes so far that I haven't really understood it. So there are two types of flags you can attach to volumes that you mount inside a Docker container. So there is a thing called delegated and a thing called cached. And more or less the documentation says something like delegated has the lowest consistency guarantees. So there is some eventual consistency. So you create a file somewhere in the container and only maybe a second later it pops up on your host machine. Whereas if you don't use any of these flags, it's synced. But of course, I mean, if you do this syncing, that becomes a bottleneck. I mean, if you write many files, it will become a problem. And then cached, it has some stronger guarantees. So somehow it means the container lags behind. So if you create something on the host file, it is only a second later in your container. But there's also a completely different approach than mounting actually your file system inside the container. There's, for example, Docker sync or rsync. So this means you just sync your files with a command. So, I mean, most of you might know rsync, for example, so you can just say, okay, so if there's a file newly created here, just sync it to the other side, or if there is a change, just sync it over there. So, now there is the next crazy first step. So we are here at a Python conference. So we want to dig deep into the Python part of the whole thing. So the first thing people will be like, what? Is if somebody will install a virtual env inside a Docker container. People are like, why would you do it? I mean, virtual env means I want to isolate my dependencies somehow. But if I have a Docker container already, it's isolated already, so I can install whatever I want there. So why should I install a virtual env in the first place? But it's, as always, things are not that easy. So I would say indeed it is better to use virtual env inside a Docker container. Because, I mean, even if it's a container, it is a full Linux running there, and Linux, so depending on the distribution, it will use some Python for its system things that it is doing. And so, for example, the Python versions are somehow coupled to the distribution. So maybe Debian Buster, it will ship Python 3.7. I mean, it will also ship Python 2 because some dependencies still have Python 2. But so there is some. I mean, it's not a strict coupling. But if you would, for example, delete the Python 3.7 version inside a container which is running Buster, there might be a problem. So maybe you don't realize it immediately, but maybe some point later you will figure out, oh, something breaks down. So it's easy to break this up and to break it. So just never figure with the system Python and also not with the system Python dependencies. So of course, if there is a program and it installs dependencies, Python dependencies, you should also not mess up with them. So it's in any case a better idea to use your own virtual env, even if you're inside a container. Then, so that's the point. So try to isolate also your dependencies from the system dependencies. There is an alternative to virtual env. We already heard it as well. There is PyConDE. It is quite interesting. So it's more or less a package manager plus some distribution. So there is a repository, let's say, and some environment manager, which would be the alternative to virtual env. So you can somehow create multiple virtual envs, which are then isolated to some other Python installations. The interesting thing is that it is also keeping track of all the non-Python dependencies. So, for example, things like NumPy, SciPy, and that's also why people really like to use PyConDE, because if you use PyConDE, mostly you don't have these problems we heard before, like there's all of a sudden things blow up. So if you use Alpine, there might be some crazy stuff happening. You might be better off to use PyConDE inside Alpine. I never tried it, but I guess if you encounter such problems, try it with PyConDE. But I mean, the last point here, admittedly, it feels even more crazy because you're shipping all the binary static files, bring it into your container, which already is more or less a container for all these files already. So this is really some inception thing. So if you think about it, for example, I mean, a problem would be something like there's a severe vulnerability in OpenSSL, for example. I mean, you patch your Docker container, but still it might be that PyConDE ships partially one of these libraries as a static binary in their packages. So I don't know if it's the case, but these things could happen. So you think you're running a safe thing, but in PyConDE it's packaged up and is running an old thing inside there. Okay, then it comes back to if you're running on a non-Linux box, please, I think it might be even the same on Linux. I don't know. I haven't tried it. But I think it's not the same problem. So, for example, if you build this virtual environment, don't put it into the same directory where you mount your source file. So it is about local development. Maybe I forgot to tell you. So, the main focus here is, I want to talk about the part where you say, I want to develop my application in a Docker container on my laptop. So it's not about shipping it into production. So of course we want to leverage their containers as well. But for this talk, I want to just if I want to do local development. For example, you can put it somewhere like temp when for something. It will speed up a lot. I made it in brackets. So these are, of course, things which might be cargo cult. So do you know what cargo cult is? So you do things because you did it always, and people said to you, like the Druid said, it speeds up your local Docker thingy. So, I mean, you would have to try it out. Sometimes things get fixed upstream, and with the next version, there is no difference anymore, and you can also do the virtual environment into your mounted volume. So I don't know, but still, it helped me sometimes. And still, I mean, it helps a lot. So if you try it in a mounted volume, it's really, really slow. There is a drawback, of course. I mean, we already saw a Docker file before. So this command, so docker run, depending on where you install your dependencies, so where you fill up your virtual environment with all your dependencies, it might be that if a new Docker container is created, you need to recreate it. I mean, not if you build it into your thing, but if you would do it afterwards, because a new container, then the virtual env is just gone. So this would be better if it's on your mounted thing, because the new container would come up and you take the old volume and put it in again. Then, so there, Florian Jetter finally arrived, so he gave me some tips. For example, this is something which might speed up. So if you, for example, have to reinstall dependencies a lot because you figure out and you want to reinstall, or you have a setup like this that you want to reinstall all the dependencies with every Docker run, then this can be quite slow, because normally pip does caching in your user directory. So it only downloads once all the stuff. So if you'd already downloaded pandas once, it doesn't download it again. It just says, oh, it's in the cache. So a trick can be mount your pip cache into the container. So explicitly make a new volume and say, okay, please take the pip cache and put it into my container. Of course, there is also dragons, because normally those wheels can be compiled for a specific architecture like Debian or whatever. So depending on how good pip is in figuring out that it's the wrong architecture, it might be safe. But still, I mean, you should be careful. For example, if you have a Debian and a Red Hat or whatever, or maybe different Python versions. I mean, this is encoded in the wheel, so there should be no problem. But still, you should think about what you're doing here. It is a bit tricky to get it working. I mean, if we have time, then I can show you how to do it afterwards. Yes. I mean, some permissions are, of course, then a bit. But that's obviously a Docker problem. So when I tried to figure that out, I was like, really? I mean, yeah. It's the question: who owns the volume? Yes. Okay. As I said before, so depending on where you install your virtual environment, things are changing. So one tip might be, so create your virtual environment already in the Docker build. So once you build your image, already include the virtual environment into your image. That way, every time you start a container, the image is already there. But the drawback is, of course, if you want to change something in your requirements, you have to rebuild the image, which takes some time. I mean, depending on what you're doing there, it's okay. And a pro tip here, we saw both versions in the talk before. So in his first Docker file, it was turned around. So the trick here is those run commands, they are cached. So Docker will figure out, oh, there's nothing changed until this run command here, so I can just use the layers before. So Docker is more or less like a pancake stack, so it puts layer on top and on top with each run command. So if you do not change a file before a run command, the run command will just be taken from the cache. So just make sure that the code that you are changing is somewhere at the last line, because I mean the code you will change all the time, and if you rebuild your image, it will just use the cache up to the last line here until the add SRV. I don't know why it's SRV, but maybe it should be SRC. So that's the tip. So in his talk, in the actual code he showed, it was in the correct order. So everything is good. Then let's go into the real thing. So putting the snake into a box. So there is a first question we have to answer ourselves. Sorry for the picture. I did it myself. I searched for one egg in a box, but didn't find a picture, so I had to do it myself. But it looks really, really bad. There is a question. So we already saw before, you can either use Docker or you can use Docker Compose. normally people would say, if I only have one container, why on earth should I use Docker Compose for it? Because Docker Compose is for orchestrating many containers, like a Redis, as we heard, and a Postgres together with a web server or something like this. If you only use one container for your unit tests, everyone would say, why should I use Docker Compose for that? So it can make sense, and the thing is, it's just the API of the thing. So Docker Compose is a command line client. That means you always have to type in those commands in the command line, and you need to figure out the commands. And if you want to put it, for example, in Git, you would need to write some wrapper bash script, which then puts in all the Docker commands you want to, for example, for mounting a volume. And that is where Docker Compose is really, really convenient, because it has a very declarative syntax with a Docker Compose YAML. So it's a YAML file. I mean, you like it or not. I mean, I'm okay with YAML. So you just declaratively declare what you want to have in your Docker container, like which volumes, which users, and so on. And it's a file, so you immediately can just put it into Git. So you have a versioned environment. So that's a real plus. Yeah, so it's command line options in Git for if you want. So that's why it makes sense to use Docker Compose. Who knows why this picture might be here at this point? Over there? For Docker Compose, exactly. So we also heard already. So Docker Compose actually really is written in Python. Indeed, I contributed back then. It was called Fig, but now it's called Docker Compose. But you can look into the project. It's quite fun because you can read it if you're a Python developer. It's different than Go. So yeah, if you want to figure out what's going on there, it's easy. So one thing we all know, if we develop Python, we always do proper packaging, so we will never just execute a script or something. I mean, we always have proper packages, and we need to install these packages. And for local development, we do a editable install, right? Anyone against it? No, that's like this. But there is a problem. So this is the thread of one of the issues with pip install editable. There are some quirks with it. So mostly it will create a directory in your local root of your source, of your package, ecc-info, and it puts in some stuff which in the end also will be in the wheel that you build. So it needs somehow the metadata of your package, and pip will always create it in the root of your package. You cannot say, please put it somewhere else. It's just, the documentation of pip says that's the advantage over Python setup develop, because it's so easy, or something like this. Now the problem is we want to mount our host file system into the Docker file system. Now if we do, for example, our pip install -e in the image, we cannot mount at image time, at image build time the file system. So things happen like you install it, but afterwards you have your fresh host file system in the Docker container, and this created directory ecc-info just vanished. So you have a broken editable install in your Docker container. And actually you think there must be a nice solution, but if you read that up, I mean, it's not completely about Docker. It's just how do we go on with editable install, and what is it, and do we still use setup tools and whatever. So it is a problem. 2 minutes. That's short. Okay. So, I mean, yeah, so there are some tricks to overcome, and maybe we just jump to the last one. So there is this Python setup develop, and you can say, please put this ecc-info over there, but then you have to set the Python path manually. So in Stack Overflow, or no, that's a blog post. So it's a nice explanation how you can do it, and then it says, it turns out this works perfectly. The only catch being we need to update the Python path to deal with our fuckery. So yeah, but that's one of the best solutions you can think of. So don't use pip, and that's somehow strange. 2019, the best solution to use Docker is to drop pip. I mean, that feels somehow strange, but it is like this. We can maybe skip this because I could not reproduce it. It might be that with Python 3.7, so I'm not an expert of such things, but we want to mount our file system into the Docker container. But there are these Python cache files. You know them. It's the PyYC in Python 2 or the PyCache folders. So Python gets, the bytecode gets generated and it gets put right next to the code. You cannot choose where to put it. It's just where the code is. So the first thing you will realize is once you execute something in your Docker container, when your source file is mounted inside, you all of a sudden have new directories on your Mac with things like Linux inside, because I mean it's the same file system mounted. So before it was an actual problem, because for example sometimes people need to do things in both Python 2.7 and Python 3. So but there's only one source directory, so those files will get mixed up, at least for the Python 2.7. I think things like this happen. And also if it's a different architecture, like different kernel version, things like this. But as I said, so I wasn't able to really reproduce it. So the error you will get is something like this. So it will hint you to please remove the PyCache file. Yeah, so I mean, it might break your thing. So, if you ever encounter such a thing, like, try to remove it, I mean, you can Google for yourself, but for me, I have an alias more or less for this thing, or we in our Slack channel, I think there is a bot. So anytime anyone asks a question, which contains, under PyCache, it just answers with type this into your file and into your thing. It just deletes all of these things. I mean, Python does not have any tooling for doing this. It just creates the things, but it will never delete them. It's sad somehow, but it is like this. So this is the best you can do if you want to mess with this. So no, so in Slack you can create it just easily. You just say keyword and message. So it's not a real bot, but it's very effective. It helped like 10 people in a month. Do I have 1 minute? Okay, so this picture, a snowflake, this is what I realize all the time. So we heard already, Docker is there to remove the snowflake problem. So it runs on my machine, but on your machine it doesn't. So we invented Docker for exactly this reason. What we are doing when we are doing local development with Docker, it happens, we build up this hugely complex Docker compose file which will mess up with all the things, like where is my pip cache, things like this. So we build a snowflake again, and it might be actually quite dangerous, because then we think we have the same in production, but it isn't, because we overwrite things here and we use it differently there. So normally it should be the case that really we use the same image in production and for local development. But as you saw, there are so many quirks, we cannot just do it. So please be aware of that. If your Docker Compose file is like 2 pages long and you mess around with everything, then you might have an actual problem. And one last remark is, so for example, if you go to a new library on Docker, on GitHub, and the first thing would be something, okay, I want to try it out, or I want to run the tests. So the first contact to any Python library might be something like a Docker Compose file, or a Docker file at least. I guess you have seen that a lot. So there is a new package, you look into it, and at least the first thing I do is I search for the Docker file, because then I can just try it and say, okay, that's fine. But I mean, we now saw we have to build in all these quirks, so there is a chance that people have to maybe set some Python path things and so on, and that's just ugly. So I think we should work on that, and I mean the entrance to what we build on and show on GitHub and present there should be something like this. So it should be easy, just do Docker up and everything is running and everything is nice without hundreds of quirks. So the last, so more or less the summary. So I think the most important thing is awareness. So at least for me, it was like, okay, I must be the most stupid developer in the world when I tried to correctly Dockerize my Python package, like with the thing with the editable install and so on. I was like, it cannot be that the status is like this, so I must be the culprit here. But so I think it's not so. There are many quirks, and you will figure many of them, and maybe already have figured them out. So you are not alone. It's not you. Probably it's just the situation. So contribute, or maybe share it also, write blog posts. So if you search for all these things, you find many blog posts and they really in detail explain what the thing is. Then I think the then of Python should work here as well. So there should be just one obvious way to Dockerize a Python application. But at the moment it's not. So I have coded something. So I have made a short template for, let's say, the tiniest properly Python package with as low cargo code and quirks as possible, but still you have the lowest barrier to entry. So you just have to set 2 environment variables. That's the user of your local computer for messing around with all the permission stuff. And that's it. So you can go there and have a look, and that's it. So hello world.